Hi, this is Islam, and in this video we are going to learn how to build logistic regression from scratch. We are already familiar with a linear regression. If you're not, please watch the linear regression video. And if you're already familiar with linear regression, logistic regression is going to be super easy for you. So let's get into the math before we get into the coding part. So usually what we do in linear regression is equal to y equal mx plus b. We use gradient descent algorithm to find m, and we find b. Then we pass the value from training, or like let's say trained data, or the the data that we want to predict with, to predict the data, right? Logistic regression does this, like have have a similar approach, but we need to pass the same equation to a different function to create a probability. In if I'm giving before I confuse you, linear regression and logistic regression both are not regression model. Logistic regression is a classification model. You have to be remember that. Do not forget that. That's an important thing. Okay, so we have y. What we are going to do in logistic regression is we passes this to a function, let's say g of z, then it outputs 1 by 1 plus exponential of minus z. Okay, what this function does is it takes a value that is an uh, let's say 0 to infinity, or like any value between like minus infinity to infinity, and put it in between 0 and 1. Okay, now the logistic regression is not complete. We need to do one more thing. What it's going to do is, imagine we have a value of 1000 as y, and we are putting it between 0 and 1. Let's say if the value is like 0.4, we can have a threshold value which depends on many things, the data, the how many type of classification are we dealing with. Let's say if it normally is usually taken as 0.5. It's not a strict rule or something. It's just a basic convention. 0.5 threshold, and classify the probability between 0 and 1 into different classes. For example, if I am taking a binary classification problem and my threshold is 0.1, and the two value that I got predicted is 0.5 and one is 0.6, these two are classified into different classes because of this threshold value. Okay, so let's get into the code real quickly. We can do this really fast, because if you're already familiar with linear regression, this is so simple. So this is the same code of linear regression that we had done previously. If you look at this is the same code. I just changed the name, and also I loaded some uh, data here, classification based data, to predict. So the first thing that we need to add is to add a sigmoid function which takes in z, and we return it. If you look at the code, yeah, 1 plus 1 by 1 plus np dot exponential np dot exponential of minus z. Okay, now okay, let me take that code really quickly. Okay, now what we're going to do is, so we already got the equation here. Now Now we need to do is do that here. We need to predict that sigmoid probability, the probability with the value between 0 and 1. So let me call that function here. So the real y prediction is cell dot sigmoid of z. Okay, and also we're going to do that here. Here we're going to, since that's the fitting part, that the rest of it, the code works perfect. Now the prediction part, we need to be careful of the threshold. We need to be we should not forget to add the threshold is the main part. Okay, so what I'm going to do is to return a list with 0 f self dot sigmoid of I is less than, let's say, we need to add a threshold, right? So let's self dot thresh, this will be 0.5. You can do any, you can take anything. 0.5 threshold less than okay, self dot thresh else 1 for I n. Okay, why am I doing for I n prediction? Okay, voila, we done it. Now this we need to call the function. This is logistic regression extreme, this class log dot fit extreme y train overflow encounter. Let's see there. I'm terribly sorry. I just spent 2 minutes for just doing the simple mistake. I just need to add this in a bracket. So after that, it's completely fitted. Now we can predict log dot predict x test. Okay. Why is it? Let's do some of, sorry. What am I doing? Okay, we got log dot predict, which is this. And now we can, what we can do is we have this prediction, and we can pass that to classification report y test and prediction. Let's print that. Okay, the score is terrible. There's a reason for that. Yeah, there's a reason. There's actually two reasons for that. The score is this terrible. It's because like now it's correct, but previously it was bad. The accuracy was really bad because we didn't really have a really good data set. I just created this, make this data set classification data set from a regression with some filtering with NumPy. But without that, our code works perfectly. I have a doubt of this being overfitted, but you can check that out. And I'm happy the accuracy is really 1. that's how you make logistic regression from scratch. I'll be coming back with other algorithms like decision tree, random forest classification, etc., and it will give you more in-depth knowledge in machine learning too. So till we see again, bye.